Hey everybody, welcome back. I just want to let you know I fixed a couple errors off screen. Everything in the analysis we saw was fine. Everything we saw is good. It's just that I was using some variables in the wrong way, and if you ran all the code again, it wasn't quite right. So today is awesome because we implemented all of this stuff in NumPy, and we got comfortable with NumPy. We got comfortable with the algorithm of multiple linear regression, except I'm going to get rid of most of what we have. I'm going to keep the code, except we don't really care about our implementation at this point because we are happy with understanding it, except we want to use somebody else's that is actually a lot better than ours in every possible way. So here we have sklearn or Scikit-Learn's linear model or linear regression. Okay, it's extremely easy to use. What we're going to do is something pretty similar to this, and so I'm actually just going to copy this part right here. So from sklearn.linearModel, import linear regression. Okay, it's going to be a class which is used to make linear models, and it's not difficult to use at all. So here we have line, I'll just say line, is equal to linear regression. That's just linear regression, and then bracket bracket. Okay, and that does nothing really, it just makes an object. And now that we have this thing line, I'll just output that for you. It's a linear regression that is not trained. Okay, it doesn't have any data, it doesn't have any sort of parameters involved with it. To train this thing, we're going to need to give it data, and so we'll do .fit, and then it wants an x and a y, except this x, it's not going to want that first column to be ones. That was for our implementation, and it's just because that's how linear regression really is underneath, except for a customer or user point of view, they really don't want the first column to be just useless ones, and so our matrix here is going to be just the information. So the first column is going to be for the first x variable, the second column for the second x variable, and so on. And so luckily that's very easy to get. If we have, and I'll just use the same data here, so random x train, if we have this, well, that starts with all ones, and then all we can do is just get the different columns. So we'll say all of the rows, and then we want not the first column, but up until the end, and we do that in Python or NumPy with 1:, and so there you go, that's it. So training this model is very, very easy. We just plug in our X matrix here, which is this one, and then the Y is going to be random Y train. That's the associated labels with that. And then after that, sorry, I always do this. That's not the right spot to put that. You want to make sure to put that in fit. And then now after that, our model is considered trained. Okay, so we have a beta vector underneath. It's a linear model, and it tried to minimize the MSE, just like ours did, except we don't see all of that code right now. So okay, we have a beta vector. We can access that, it turns out, as line.intercept underscore. Okay, so that would be, that is the beta not term, the beta not value. We also have line.coif, and that is the other betas. Okay, so anything not the intercept, it's just the values that are beta 1, beta 2 for our example. Okay, so if I output that, we get a beta naught of 3.25, a beta 1 of 1.1, and a beta 2 of 1.5. Well, let's compare this, what this output would be, to our other model. Okay, so we have to get the MSE for this, and to do that, it's very, very easy. In fact, we're actually fine with our MSE function. There's nothing wrong with it. And so what we can do, well, we need y's and y hats. The y's are just going to be the random y train. This will be for the training for now. And so it's that. And then to actually make predictions with the model, it's already actually done these predictions because this is training data. But to do it again, we would have line, that's Q, line dot predict. And then we just need to give that an X matrix, and we'll give it random X train. We'll give it this exact thing again. Okay, so then after we do that, module object is not callable. What did I do here? Random, that is not at all what I tried to do. And invalid syntax. Okay, sorry about that. So 0.185, which is exactly the same as our other one got. All right, unsurprising, it did the exact same thing, okay? And what we can do again is get the testing data. So what we'll do is get the MSE of random, I'll just change this thing to test, and then we'll predict based off of the test. And again, the test, it also had the first column of ones, so that we actually have to do this again. And so the MSE is going to be 1.66, and that's what the train is, or the test is over here as well. Okay, so it did exactly the same thing as our other model. And We did it in Scikit-Learn, which is so much better. It's going to do it a lot faster. It's a lot cleaner. We also don't have to worry about that column of ones that is just kind of an annoyance. And yeah, I hope that made sense. If it was fun, please drop a like, and I will see you in the next video.